All right, hello everyone. Today is February 23rd. Kind of late today because I had a lot to do during the day. Now, before we get started, we got a little bit stuck yesterday on a syntax called iterator in iterator. So I'm going to actually pull up yesterday's file. So kind of just explain uh, what it actually is, the iterator thing. All right, here is the file from yesterday. And let's get it smaller so I can kind of see. So the last solution, solution 5 from Mr. Parkman, he had this kind of setup to evaluate whether a word is in S. So it says it equals iterate, so we turn the string into an iterator, and then we use this. So when we call, so letter is a word, right? And for each letter in the word, we want to see whether this letter is in the string S as well. And we use an iterator as a very smart way to do this, because when we call letter in iterator, imagine letter in a string, right? It's basically just go one by one, search the string. So it's the same when we say letter in iterator. Imagine iterator just a string, and when we call this, it automatically goes one by one the letter in the iterator or the string. And the magic is once it finds that the letter is inside iterator, once it finds, and then it will return true, and the iterator will remember the current position where the search has been. And then it goes to the next letter. It will start a search from that position going on. So basically, we're doing the same as we do elsewhere, but it's just much cleaner and much easier to do this. And also, this only returns false when letter is not in iterator, so it searched through everything in the iterator and it cannot find a match. That means we have exhausted this iterator. Only when that happens, this one will return false. And imagine, if this one's false, that means iterator has been exhausted. Any remaining letter in the word will be false because iterator is already exhausted. So then it will just be all false. So this is just a very nice trick that we don't really know before, but now we do. So kudos to Mr. Parkman. All right, let's take a look at today. Hopefully it's not too difficult because I really don't have a lot of time. So I want to make it as simple as possible. Search a 2D matrix 2. 2 means it's not going to be easy. It's going to be like a medium question. Let's see. Efficient algorithm that searches a target value in an n times n matrix. The matrix has following properties. Yeah, if there's no property, there's only one way to search. Integers in each row are sorted in ascending from left to right. I have seen something similar before. Maybe I've done search a 2D matrix 1. Integers in each column are sorted in ascending from top to bottom. So ascending and ascending. And then we want to find target 5, okay? We want to find target 20, okay? Each row are sorted and each columns are sorted. So when we given a number, we know the smallest okay, so we give them 5. We do a binary search, so we know the 5 can only be here, right? Because it can be here or here, but it cannot be any because it's ascending. So 5 can only be among these two. And then we do a binary search in these two column. For 20, it can be in any one of them. Oh my god. Yeah, 20 can be any one of them. So there's, 20 can be any one of them. Oh, it can do a column-wise and then a row-wise. So 20, it has to be, it can be any one of them. And we'll go here, 20. It can also be any one of them. So it's not really helping. Or we can also check the last row. Oh, how do we make it very efficient? So we know that it's always increasing every. I mean, we can do. How big is it? Oh my God, 300. It's not too bad. It's not too bad. We can just do. I mean, rows will be easier to handle, so we can do rows. Yeah, so like if it's 5, then it cannot be these two, so it has to be these 3, and then we just search. So it's going to be, the worst case is going to be search through all the column, all the rows, and each time is going to be log 300. All right, so it's n, but it's not. So we can pick the smaller one, right? We pick the smaller one to go, and the larger one we're going to do the log. Yeah, but it will be hard if you want to use binary search, unless you want to write it yourself. If you don't want to write it yourself, we have to go rows, which means we have to go through many rows if the rows are significantly more than a column. But apparently that's not what we want. We probably just write it ourselves, the binary search. Yeah, I think we can. Oh, wow, this is. Yeah, we can write it. Is there any better way to handle this? So we give a number, right? Give a number. We know these are the smallest value in a row, and these are the biggest value in each row, right? So we're given a number. It doesn't really work. I mean, it does. It kind of does. I was thinking about 20, right? I'm thinking about 20. Think about 20, and we check each one. We check front and back, right? Check front and back, each row, front and back. So we know it's not in the first row, not in the second row. Could be these 3 rows. And we check also the column, not in this. It can be this. It can be so. We know it can be these 4 columns just by the range. Could be these 4 columns and these 3 rows. So we narrow it down. It has to be in this smaller matrix. So we do 1 round. So we narrow it down to a smaller matrix, and then we run binary search on the smaller matrix, row by row, using the custom method. You think this will be a better way? Yeah, because this is going to be 300. 300 times, so it's 600 times, and we can shrink it down. For 5, if you think about it, we go as a good, 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 no good, 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 no good. So we go first 2 columns and the first 3 rows. So we shrink it down to this range, right? And then we run binary search. Oh, we can actually keep going, right? Keep going, and then this, we know this row is no good. This is good. This is good. So we have 2 rows, and this column is no good, and only now we narrow it down to this, and we can do again. We run again. If there's no change, then we exit. All right. So for here, like we are ending in ending in which one? In this one, right? This we ending in this, and if you look at the columns all then this column is no good. So we have this, and we can run. Yeah, this one. Oh, then again, this one's no good because it's smaller. This one's no good, and then then it's so we can just use the smallest and biggest to shrink it down, right? Shrink it down. So just n plus n, and every time I'm not sure if that's the most efficient. All right. Let's do the easiest way. All right. Let's try the easiest way, which is the easiest way will be row by row. We just run binary search. That's it. All right. That's it. We decide to be lazy on this. All right. So we say from bisect, import bisect. Doesn't matter bisect left or bisect right. All right, and we just say for row in matrix and index is equal to bisect left row target. All right, and then if it's the same, then we'll go for the left. So we say +1. Actually, right. I can go -1. Yeah, I think go right will be easier. All right, and then we say if row index -1 equals to target, return true, else return false. I'm gonna sneeze very soon. Holding it. I'm holding it. Oh, I think I held it. All right, and then 20 will give us false. This is we might pass. Yeah, we actually pass. Oh, it's actually very fast. Oh, then this might be a easy question then. I was thinking this probably will become slow. All right. All right. I don't know how to say about this. I thought it's going to be a bit difficult. I mean, we have the other method, right? To shrink it down, but it requires writing a lot more code. And after we shrink it down, we still do binary search. Shrink it down. How do we? What's the And actually, it might not be even faster because shrink it down. We have to run m plus n. Oh, it's m plus n. So run m plus n, and we get a result, and then we run it again. So the worst case will be everybody is good. If everybody's good, then we do the binary search. If not, we shrink it down. It might be, I don't know. All right, I don't want to think too much. I want to just go and then check if this idea other people have explored. Yeah, oh yeah, I did a first one. I don't know. It's oh, it has m plus n. Wow, m plus n. There is m plus n. All right. Hold on. Let's summarize this one first. This is a very straightforward solution. We go row by row and run a binary search. That's it. That's it. I mean, this is apparently not the best solution because we only used one condition, that is each row is in ascending order. We did not use the other condition. So this is n rows, n columns, right? I think that's the... All right, so we know there's a better one. I kind of want to do it myself. Yeah, m, so it's going to be m log n. I got 148 milliseconds and a 99% ranking. Now this is surprising. I think it's just, you know, it's optimized. All right, so let's try. So apparently there could be m plus n, right? So we search this. And we search this. I mean, so we do search. I mean, the ideal I have earlier, is it m plus n? Well, you search m times, right? M times, we are only able to, because every time we search, so we have the beginning, we have the end, so we can eliminate, right? We can eliminate some. And I'm kind of just stuck in the old mindset. I'm just thinking, okay, we search through and then we can eliminate some columns or some rows, and then we get to a smaller one, and we do that again, and we do that again. But what if we cannot, right? What if, let's say we have a number? Well, it's actually not really possible. We have a number, most likely we can eliminate something, right? That is interesting. And it didn't really say, like, the numbers can also repeat itself. Yeah, it's not, yeah, we only use one, right? How can we use the other? So each row, we cannot, if I say each row, I do something with a column. It has to be global, right? For the rows, I identify where I'm supposed to be. Like it's 20, I say I can be any of the rows. No, actually not. I can only be these 3 rows. So I can only be these 3 rows, so we shrink the problem to these 3 rows. And then we check the columns, 20. it can be all of these 20, right? 20. No, it cannot be this, so it can be this. Then we check the row again, 20. And then this cannot be, so we have something this. Then we check the column again, 20, 20, 20, boom, then it's no, right? If it's 5, we check the row first. Good, 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 bad, bad. Check the column, bad, good, bad, bad, bad. Check the rows, good. Huh, maybe this is the solution. Is this m plus n? I mean, the first one I do m times. The second one is like n times. I mean, if a number does not exist, this method does lead to a solution. Definitely lead to a solution because it's just constantly eliminating. But if it does find, maybe this is the n plus n. I actually don't know if it is n plus n. I mean, it's like, oh man, we eliminate and then we do it again. Eliminate, we do it again. So overall, how many times we do? It's going to be m plus some level of m's plus. So the worst case will be m plus. Isn't the worst case going to be every time you don't eliminate anything? You don't eliminate anything? But one of the directions will have to eliminate. Right? One of the directions has to eliminate because it cannot be stable. It cannot just like we have this matrix and then it just doesn't move. Because if it doesn't fit, then it would it be like one. Yeah, it could be. Let's see. Will we have a situation? Yeah, I'm just. Yeah, I'm just playing with the numbers and see if we can find, like, say, a value that it cannot be eliminated from any of them. It will all be eliminated. It will be eliminated. It will be eliminated. What is the rule here? Yeah, I think it will. Like, no matter what, it will be eliminated. It will be narrowed down to like a single value in very short amount of times. Let's try this. I'm not sure if this is n plus n, but we definitely can try. So the idea, as I've laid it out, we're just going to go row first and then column. We'll probably need to write a function that's just a check, right? So we need to know the start. So we have to know top left, bottom right. Let's just say TL, top left, bottom right. And this will give us, what does it give us? It give us all right. Now I think it'll be easier just to say. Now this is okay. What does this give us? This give us the next round. So this should give us a next round top left and bottom right. Okay, so give us a tuple of a tuple. And I want these to both be tuples. I didn't even run any test cases on this. That is very interesting. All right, so this is what we want. So we're coming in, have a tuple and a tuple. So we just iterate through. Let's not return tuple. It's just too complicated. We just say, oh, what should be the left, right, top, bottom. Left gonna be int, right gonna be int. That determines the width, and top gonna be int, bottom gonna be the int as well. So we're gonna just return a tuple, which is all this, right? And then we're just gonna do for, let's go, say go row first, and then go column, and go row, and then go column. How do we do like a row, column, backup, row, column? So for row, it's going to be for, let's say, I in range left, top to bottom, right? Top to bottom, plus 1. So I in this range, and then we're going to check the front and back. So we're going to check if 1 is not, then yeah, if 1 does not fit, what is possible? Like the top row doesn't fit. The top row fits, but the next row doesn't fit. It might be, but it's actually, so it doesn't fit doesn't mean it doesn't fit. It's like it's either it's too small. If it's too small on the top, it should be bigger than the bottom. So I do think if the top, because the top will all be smaller than, and the right will all be bigger than. So if the range on the left does not fit, if the range on the top does not fit a certain number, then the range at the bottom will never fit. If the range at the top fit, if the range at the top is too big, then the range at the bottom will no longer. No. We'll give a lot of dry food. Yeah. All right, hold on. I need to do this first. All right, back to this. So what I'm thinking is if the top row is out of range, which means the target is either too small. If the target is too small, then the top row, then we just end it, because the bottom rows will not be any better. If the top row is too small, then we have to go for the bottom row. Yeah, I think this is how it is. So we're gonna have a small big will equal to matrix I, that's the row, and we have a left and matrix I and a right. If, so we go top to bottom, if it's too big, all right, if small is larger than the target, then we can just break. There's no point going on. Else, if small else elif, if the big is too small, then we have to keep going. Right? If the big is too small, we have to keep going. How do we record? Which one is the start? Oh man, the logic is not that straightforward. I think we also need a new top and new bottom. Should be top and bottom, right? And then if the big is smaller than target, then we continue. Else, so this is when the small and big, it fits, right? It fits. So when it fit, what do we do? When it fit, no, the start cannot be top and bottom. The start has to be M and N. No, start. Let's just do. So the top has to be small. The top, really big number. For example, we can do math.inf, and bottom will be a big number. So math.inf. Oh, we can just do -1. That's fine. Let's import math as well. So else, we're just gonna do new top equals the min, new top, and current I, and we do the same with new bottom would be max, new bottom, and I. Right? So we keep track on the top and bottom. We keep track on the top and bottom. So we're gonna do the same thing with for J. All right. So it's going to be unleft and unright. Left will be this. That's good. So it's going to be J for J in range. This is going to be left to right. Now the big small will be so like after we go through this, we need to update. So we pass in top and bottom, but we don't really need left and right. So we pass in top and bottom, and then we're doing top and bottom, so we select top and bottom, right? And then when we do left and right, we can actually use new top and new bottom. Yes. So we go left and right. We're gonna say it's gonna be new top will be the small one. This will be J, and this will be new bottom. This will be J, and the same thing. If the small is bigger than the target, that means there's no point going on. If the big is smaller, then we keep moving. And here we're gonna update left and right. So the left will be the smaller between the J, and the right will be the max, the J. Actually, it's not really, because as we're going, the right will always be J. The left will be the smaller of, the right will always, like here, the right will always be I. And that will be Yeah, so we actually don't even need to, do we need to specify? Do we need to specify? That's a good question. So, um, if it didn't find, right? If it didn't find, and we're gonna return all these values. If anything did not find, then we will have the bottom is -1, right? Because only when it finds, we will change the bottom value. And the same with this, okay? So this is a check, right? For each round, we do a check, and then we return these values. Now, what we're gonna do, we're gonna say while true. So yeah, while true. We're gonna say left, right, top, bottom equals left will be 0, right will be len matrix -1, top will be 0, and then bottom will be matrix 0 -1, unless the matrix is empty. I don't think matrix can be empty. No, it cannot be empty. So we say while true, and we get a new round of left, right, top, bottom equals, oh, it didn't return. So we're gonna return new left, new right, new top, and new bottom. So this will equal to check left, right, top, bottom. So we check them, and we're gonna check if right is -1, which means we did not update the right, or left, not left, bottom is -1, then we just return false. Otherwise, right, and then we should be while left is not equal to left is not equal to right, and the top is not equal to bottom. Then we keep doing this, and if anyone is this, and then when it equal, then we're going to return true. Yeah, let's set up the test. Not 100% sure. This is a little bit out of my comfort zone right now. Whew. Let's take a look. So, a matrix like this, 5 will return true. And the same matrix, 20 will return false. And we're going to handle all the case this, handle the case here, so that my editor won't complain. And this will be matrix target search matrix target, and C. The first pass, the second one, what the heck? Oh, I know. Oh, so what we're going to do is, so when coming in, they're all fine, they're definitely fine. And then after this, I'm going to say if and bottom is not equal to -1, then we do this. Okay, seems like it's working. Let's try it. Again, still I'm not sure if this is a... Let's see. Oh, it took a long time. Oh, it's still judging. I think I hit a forever loop, whatever that loop is. Oh, I hit a wrong answer. Output true, expected false. Oh, I probably have to, once it come out, how's this searching going? Oh, the start is all the same. Oh my goodness. So it has to be matrix, what? Matrix left and, no left, it's gonna be top, and left equals target. This one shall work on this. Give it a shot, -5, and then -2. This one shall return false. Yeah, and if we use a sample test case, both shall work. Too soon! Let's wait. Output false, false. I do not know why. Oh no. Alright, apparently this is not right. I'm back again. Apparently this is not right. We have issue with the first one. Why would we have an issue with the first one? When it gets out, shouldn't be the same. Right, left equals right, and top equals bottom. So what is the value that we are actually having? This is interesting. What do we have? 4. That's now 5. Hold on. Why is it 4 instead of 5? We go this. So we go top 5. We say yes, 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 no, no. So we update. Top is here, bottom is here. And then we go no, yes, and no. If big, if small is big, then we break. So we have it here. So that's left and right is already converge. Top bottom doesn't converge. All right. So we enter again. So top, bottom. And left and right is the same. So it's the same. If small, large, no. If small is larger than target, no. So elif big is smaller than target, yes. We continue. This one. So we do and top. So top becomes I. It's this. Right? It's this. And bottom is also this. And then we go again. Small, then we break. Then we have this. Top bottom is here. And but this, hold on. What is going on here? Why do I print out 4? I mean, apparently left and right is correct. It's just the top and bottom is not correct. Let me print something more. Basically, I'm going to print every one of these just to check. So what we have is 1102. Wait, is this after the first round? Are we only doing it for 1 round? Oh, I think it should be or. While this or. There we go. That's right. That makes sense. We have a lot of error. All right. Yeah, this is just a little bit of logic was wrong. Unexpected. Let's actually put the other test case in here. So we have a test case of -5, -2. This will be false. And we pass. All right, let's try it again. Runtime error. List index out of range. What the heck? Why? Why? I left and I right. Why is the list index out of range? Didn't make any sense, man. Did not make any sense. Yeah, I know. Like, if you want to get to the nitty-gritty, it's always this. That should be true. Always this type of edge cases can really catch you. It's like, why you run it again? You know it's not gonna be right. Hold on. Let's see. It's our first call and have issues. A first call. I mean, left and right. I think I know. Oh my god. Oh my goodness, now we have infinite loop. Top, bottom, left and right. Yes. Then what? From top to bottom. So top is 1, top is 0, bottom is 0 as well. So I is 0. 0, left and right. Small. Alright, why would it be infinite loop? Hopefully these all pass. Wait, this one give me infinite loop. What the hell? Why? Land matrix is 0. No, land matrix is 1. Land matrix 0 is... Hold on. Land matrix, right? Land matrix is the number of rows, which is the bottom. All right, so we have 1 row. And this is column, which is 2. We have 1. Right, so it goes in. So I is 0. I is only one value. And small, this is not true. This is not true. So we update. And let's just put some value here. And top and bottom. And print and left and right. Oh, Jesus. So we just keep feeding back. So this is 0, 0, and left and right. So left and right did not change. Ah, because we're repeating the value, that's why. Okay. Okay, left and right. Okay, yeah, it did not change. What do we do? If it does not change, return out. And then we are going to so we know when it's false, but when it's true is hard to say. So left and right, or we can add I want to handle it outside, right? Handle it outside. It's just yeah. I imagine you can have an issue like I'm actually gonna write it by myself, like this. You know, we have 2, 2, and 2, 2, which is completely valid. This has to be true as well, and just nothing moves. Nothing in this moves. Like how do we deal with this? Well, we deal with this if so we do this, right? And then when we do the second check, we have a more elif. So elif. Yes, we can just to handle this situation, we do another elif. Small is equal to target. And it could be big equal to target or small equal to target. So we're trying to just catch this situation where it's just a string of values is all the same, right? If they're not the same, then it's completely fine. But if they are the same, so what we're saying is we have a value that is good. So we're going to intentionally I'm going to return right here. I'm going to return unleft because not unleft. I'm going to return left, right, J, and J. No. God, come on. Yes, J and J, untop and untop. That's it. So if we find it, we're just going to do it. Actually, we're going to do the same up there. All right, but instead of return j and j, this one will return left, left, and I, right? And we run these two. Oh, what the hell? There's no. Yeah, and these two pass, and the other three also pass. Yeah, I feel this is way too convoluted. Way too convoluted. I'm almost certain that the actual solution will be much nicer than this. It actually runs longer. It's another solution of mine in an attempt to search to get a O m plus n solution. However, this one feels very convoluted. I'm trying to go row first to eliminate column, to eliminate rows that are out of range with regard to target. Then go columns to eliminate columns that are out of range. Repeat this process until we either find the target or not find the until we find the target or realize that the target does not exist. I am not sure of the runtime. Could be O m plus n, but feels. But I don't know. We run at 168 milliseconds with 52% ranking. So this is handle a situation where of repeated numbers. Handle situation of repeated numbers. Yep. And we can do the same here. Let's also handle this. Not found. All right, let's check the solutions. I'm curious. Okay. We start searching from top right corner. Top right corner. If the target is greater, then the target cannot be in the entire row. Okay. The target is less, the target cannot be in the entire column. Hold on. Let's start from here. If the target is larger than this value, no. If target is smaller, then we have to move this way. If target is larger, we move this way. If target is smaller, we move this way. I think yeah. So if target is larger than this value, then we know if target is larger than this value, then this row is no good. So we just move down. If it's larger, then we move down. If it's smaller, we move left. Ah, yes. Ah, yes. Yes, that's n plus n. We start from here. If target is smaller, that means this one's no good. We have to move here. If target is smaller, we're talking 5. We'll move here. Move here. It's larger, we'll move down. Oh, wow. Oh, wow. Yeah. Smart. It's. I don't know. Should I say I'm actually close? No, you're not. You're not close at all, man. All right. So we're gonna say ij equals. I will be 0. J will be len. Matrix 0 minus 1. Say while true. For ever loop. If matrix I j is larger than the target, right? It's too big. Then we have to go I plus equals 1. Elif matrix ij is smaller than target, then j minus equals 1. And else return true. And when do we get out? Well, I has to be larger than 0. No, I has to be smaller than len matrix, and j it has to be larger than 0. And if we exit, we're gonna return false. Let's try it. Number 3. Oh, we have issue. Answer is true, result is false. Why? Infinite 5. ij, j, yeah. Larger, yeah. No. Matrix is larger than target. Matrix is larger than the target. Then, oh, I think I got it wrong. I got it wrong. It's this has to be j. Yeah, it's if it's larger, then we j, and then this is I. There we go. Oh man, look at this. Look at this. Oh yeah. Why is this so much? Anyway, this is the correct solution. The right solution. The correct solution. Very smart. We start from top right corner and zigzag towards the target. This is O, M plus N. Yeah, worst scenario, just we have to go all the way to the left and all the way to the bottom. That's the worst situation. I am surprised that it's actually slower, much slower. But you know, it's just Python has a spread. Yeah, I don't even need to. This is good. But I want to top right. Yeah. Oh my god. One-liner. Oh. Ah. It did get accepted. This is nowhere near code golf. No point in sharing the same solution. Yeah, that's true. Yeah. But, I mean, there are so many garbage. What the heck? You do not call Mr. Pacman stuff garbage. I'm gonna downvote you again. Mr. Pacman is incredibly genius. Right? Incredibly genius. But anyway, this is so I'm gonna say inspiration. Inspired by here. All right. This is good. We had a good. I did not expect to spend that long today. I mean, it's we did get it done very fast, but you know, it's can't help it, right? Can't help it. Yeah. Although it took some time, and then it's longer than how I want it to be, but at the end, I am very satisfied that we know the real good solution. Anyway, that'll be it. We'll see you guys tomorrow and face the new challenge.